Hey, welcome back to the channel. So when we got to the end of our last video, we got to the stage where we could smash pieces off of Hey, welcome back to the channel. So when we finished our last video, we got to the stage where we could smash pieces off of the chair, but when we did, we ended up with these floating bits at the top here. And so the last thing we're going to do before I leave you guys to figure it out yourselves and do whatever crazy wild stuff you do, is we're going to fix these. Now this might sound a bit complicated, but like we've said before, it's just about knowing how to use the tools, what order to do things in, how we line things up. So let's go back for a moment to the API. Within the API, we've got some really cool stuff here. We've got select mesh elements in a box. So as long as we can define a box where we want to select things, we can actually select parts of the mesh the way that we would in a modeling software. We've also got expand mesh selection to connected. And so that means we can actually find all the pieces that are connected to a singular point. So if you think about the process of what we want to do here, we have got an object that we have punched holes in. Okay, so let's say we've punched holes all the way over here, like this. If we can select some parts of this object, so let's say we selected everything in here, and then we expand this selection to everything that's still connected, then what's not connected is not selected. Okay, so all we need to do is do this and then invert this selection, and that'll give us all the parts that aren't selected, and then copy that to a different object and then delete it from the original, and there we go. So sounds like a complicated problem. It's not really when you talk through it, and that's the thing with system design. It's just about understand the tools, figure out the order in which you're going to put them in, and then you can do amazing things. So let's go in here, and just keep things from getting too convoluted, I'm going to make a new function here. I'm going to call it split orphaned tries. And let's go back here to our sphere punch, and all I want to do is just, this is what we want to run after we're finished with our sphere punch. Within split orphan tries, first thing we need to do is we need to get this point here, well, this point here. Okay, so we've got our object. We want to get the bottom of that object. So before, when we were splitting our objects up, we got the center point. So we can just do the same thing we did before. Dynamic mesh, and we can get the center. So get mesh volume area center. That gives us the center of mass for our mesh. Now we want to drop down to the bottom of this. Thankfully, because the mesh is contained within a component, so if we get their dynamic mesh component, we can get the bounds of a component, which basically tells us how big, the bounds is basically like it draws a big box around the component. Now, the box extent here, you can just split this out, because we don't actually want, like if we used, let's draw this in 3D. So if we use the actual box extent, it would give us the bottom corner. We just want the bottom in the middle. So we just only take the Z component. We do center of mass minus, and again I'm going to split this apart. and just plug the Z in there. That should give us the position for our box. So let's get our dynamic mesh again. Select elements in a box. And we want to make our box. So let's drag off here and type make, see what we've got. Center size, center extents. Let's go center size. So our center should be here. And we should have, let's just make this wide and long and short. So it's 500, 550. And then just to check that this is working, we're going to say delete selected triangles from mesh. Connect the mesh up. Obviously not what we want to do in the final thing, but this is just to test that that's actually finding the right box. Okay, and you can see the bottom immediately disappeared from that there. I'm actually going to quickly duplicate this and add a couch here. This is a bit easier to see on the couch. So that was working. So let's take this one step further. So we want to expand this selection to all the connected pieces that are connected to what we've selected. And then we want to take this selection and we want to invert it. It needs the mesh as well. And then let's try again. Let's delete selected triangles from mesh. Okay, so this shouldn't delete anything until we've disconnected a piece. Okay, so it's not deleting anything. Break that. And there you go. Let's try it over here. So the collision on these debris pieces is really annoying. Okay, so that's broken. Nope, not quite broken yet. There you go. So it's able to delete the pieces that we actually want to copy over to another mesh. So let's do the final step now. So what we're going to do is I'm going to spawn an actor here, and I'm not going to spawn a destructible mesh actor because the destructible mesh requires complex physics to be enabled for the projectiles to hit properly on the mesh. And we can't do that with a physics object. If you try and turn physics on, you just can't turn physics on if you're using complex collision. What I am going to do is I'm going to spawn a dynamic mesh actor, which is a type of actor that comes with a dynamic mesh component already attached. Now, why did we not use a dynamic mesh actor at the start of this? Because I didn't think to do that, and actually it would have been very clever, and I will make another video about why that would actually be better and would save us some time. But for now, let's plow ahead. Spawn actor from class. We take a dynamic mesh actor, and we want this dynamic mesh actor to be an exact clone of our main actor. So let's get the actor transform, so it's going to have the same location, scale and rotation. We can get the dynamic mesh component from this, and then we can get the dynamic mesh from that component. And what we want to do is copy mesh selection to mesh. Now again, it's going to hook this up into target mesh. This node's a wee bit confusing because you would think target is where we're copying to. It's not. If you look under target, you've got copy to submesh. So this is what we want to copy to. Our dynamic mesh, our existing dynamic mesh is what we're copying from. And then we need our selection, our inverted selection from over here. So we'll drag this all the way over and make some reroute nodes so that's nice and clear. All right. Now, we need this to be set up the same way that we set our debris pieces up. We want this to be physics enabled. So first things first, let's set the collision. Nope. Dynamic mesh component for most of this. So let's set the collision from the mesh, set dynamic collision from mesh. And we have our copy to submesh again. So from the copy to submesh, which is what we just created. Then set collision enabled. And we want query and physics. And then finally set simulate physics. True. Yes, we want to simulate physics. And then finally we go back to our regular dynamic mesh. And we see delete selected triangles from mesh. And we're going to bring this all the way over here. Okay, so we're spawning our new actor, we're copying the mesh in, we're setting the collision up. Forgot one thing, which is we want this to look just like our usual mesh. So let's take one last reroute node here and let's set materials, configure material set, there it is. So we give it the materials of our mesh so it will look just like it. Now if I compile, save, go back in here. Oh, there we go. And oh, almost there we go. Look at that. So we have our destructible mesh. There it is. Now, this is where I'm going to end this series. I've shown you everything I know how to do. There's a few caveats with this. So this system here, personally, if it were me, I would like it if it found the world lowest point when it was doing this destruction stuff, but it doesn't. I'll show you this right now. It gets a bit confused when you start to rotate it in different ways. Works fine as long as the rotation is only on Z. As soon as it's tilted and rocked, it gets a little confused. I'm still working on that. It's a tricky thing. But one of the things about system design is it's never going to be perfect. It's never going to work exactly the way you want it to. This would be good enough for me to then take to the team and say, well, this is the situation. As long as you don't, spin our destructible objects, as long as they're just rotated on Z, in that way, they'll work fine. There's loads of stuff I would do. Things I skipped in this video. I didn't play with the collision channels. The debris is really annoying. If you set up collision channels, you can make sure that the debris collides with other static objects and collides with itself, but doesn't collide with the player, and that makes moving around a lot nicer. I didn't have the debris disappear after a little while. Other than that, I didn't add Niagara particle effects, which would be the next thing to sort of mask a little bit of the awkwardness of the explosion. But there's loads you can do with this. I really can't wait to see what people get up to with Geometry Script. I don't know if I will actually do anything with this from this point. But if you guys do, please do hit me up with a comment and let me know. If you have any questions, pop something in the comments and I'll get back to you. Yeah, thanks for watching this series, and I hope you've enjoyed it. I hope you've learned some stuff from it, and I'll see you again for the next one.